So we're back again, and we're looking at some more pre-calculus review as we get ready for calculus. Here we're trying to find domain and range. So find the domain and range of the function f of x equals x squared minus 4. So the thing to remember, domain, that means x values, and range, that means your y values. So there are a couple of ways to tackle this. One way to do it, and I think the easiest way, possibly, is by looking at the graph. So if you grab your graphing calculator, you should be able to graph this by hand, but if you were to look at the graph of f of x equals x squared minus 4, we should recognize that, yeah, that's just a parabola. The minus 4 is going to bump it down 4, and so your parabola is going to look something like this, where that distance right there, that's negative 4, and it goes on and on forever. It doesn't really go vertical, it widens out, but you get the idea. So when I look at this graph, domain, because that parabola just keeps getting wider and wider and wider, I can plug in any x value. That's what domain is. What x value am I allowed to plug in? Well, I could plug in any number and square it. I could take any number and subtract 4 from it. So my domain is going to be all real numbers. Now, the way that we write all real numbers in interval notation, where do the real numbers start? Well, they start at negative infinity, and they end at positive infinity. And then we have different ways to wrap up intervals. We can wrap up intervals with parentheses, or we can wrap them up with brackets. A bracket means you can reach that value. A parenthesis means you cannot have that value. Well, infinity you can't possibly reach. Infinity is not a number. You treat it like a number sometimes. That's what causes you to have issues with infinity. Infinity is not a specific number. You can't count to it. So since I can never get to infinity or negative infinity, we wrap that up in parentheses instead of brackets. And so my x values could be any x value, any real number, which is the only thing that we'll deal with in calculus. For the range is the y values. When I look at this picture, I don't have all y values. I do not have a y value here at negative 5. I do not have a y value here at negative 10. I don't have a y value here at negative 2 billion. My first y value starts here at negative 4. And so when I am going to write my range is going to start at negative 4. As far as the highest y value as this graph goes up, this graph has a couple of times where the y value is negative 1. This graph has a couple of times where the y value is 5. This graph has a couple of times where the y value is 115. Doesn't matter how many times we reach it, as long as it reaches it once. This graph can go up as high as we want it to go, and so on this graph, the range will go from negative and 4 all the way to infinity. Now, as far as infinity is concerned, infinity always gets a parenthesis around it because you can never reach infinity. Negative 4, however, is it possible for me to plug in an x value, some number into this x value right here, and then work it out by squaring that value and then subtracting 4 to end up at negative 4? Well, yeah, if we plug in 0. 0 squared is 0. 0 minus 4 is negative 4. I can actually get this y value of negative 4. And since I can get that y value, we wrap up the range, the interval, with a bracket around negative 4 instead of a parenthesis, because I can actually reach it. So our domain is negative infinity to positive infinity. Our range goes from negative 4 to infinity. Now that's the way you do it with a graph. What if you don't have a graph? What if you don't have a graphing calculator? It's the non-calculator portion of an AP test. Well, say goodbye to the graph then. I can still figure out the domain and range. General rules for domain and range. In general, if there's no radical, if there's no square root, I'm sorry, that is a radical, if there's no logarithm of any type, and if there's no fraction, well then generally speaking, this does not hold true always, but generally speaking your domain is going to be negative infinity to positive infinity. See, because when you're doing domain, you're trying to figure out what can you plug in for x. Well, I can square any number. I can add and subtract any number to any number. I can multiply and divide any number to any number, except I can't divide by 0, which is why this whole no fraction thing is there. However, when it comes to radicals, I cannot take the square root of every number. I can't take the square root of negatives. We will not deal with that. That's imaginary numbers. And so radicals screw us up. However, we have to be careful. Third roots, I can do the cube root of -8. It's -2. So we have to be very, very careful with certain radicals. Logarithms, you cannot take the logarithm of a negative value. There's no such thing as the natural log of -7. It doesn't exist because you can't raise something to a power to make it be negative. So those are the things that really screw up plugging numbers in. But squaring numbers, no problem. Adding and subtracting the numbers, no problem. So when I don't have anything like that, our domain typically is negative infinity to positive infinity. When we do have those types of things, we have to examine it. As far as range is concerned, that can be a little bit trickier. What you have to look at is what is true about when you square a number. When I square a number, the lowest it could possibly be is 0. You can't get negatives when you square something. It's impossible to square a number and get -1 outside of imaginary numbers, which we don't deal with. So I can't square any real numbers to get to -1, -2, -3, so the lowest that x squared can be is 0. If that's the lowest it can be, that might be my range, my lowest value on my range, but wait, we're then subtracting 4 from that. So if the lowest that x squared can be is 0, and then we subtract 4, then the lowest possible value I can get is -4, which is why our range starts there. You got to play around with them. I highly recommend looking at graphs when you do it, but definitely try and figure it out before you look at the graph, because that'll help you look out for domain and range, even if you don't have a graphing calculator or can't visualize what the graph looks like.